Right, so on question 5, we got 8 footballs in a store cupboard. One is yellow and the others are white. A pupil takes 2 footballs out of the cupboard at random. What is the probability that one of them is a yellow ball? So already I've set up my tree to represent this situation. We notice that we have 8 footballs in total. So this is our total number of balls, and one of them is yellow. So that means your probability of getting the yellow ball when you take the first one out is going to be 1 out of 8. Okay, and so that means there are 7 white balls in the cupboard. So that would be 7 out of 8 for white. Now, when you take out your yellow ball, and there's only one ball, isn't there? So when you take out that ball, you're going to have 0 out of 7. So you can tell it's not possible to actually get 2 yellow balls. So we can write that as yellow, yellow. So 1 times 0 is 0. 0 on 7 eighths of 56. So obviously 0, because you took out a yellow ball and there's only one ball. So how can you take out another yellow ball? You cannot. So this is why you get 0 for your probability here. Okay, so when you've taken out your yellow ball, you've got all white balls left. So there are 7 white balls out of 7, like that. So this would be yellow, white. So that's going to be 7 on 7 eighths of 56, like that. And if you take out a white ball first, you'll have 7 out of 8. Take out another white ball, this would become 6 out of 7. Okay, so we reduce the balls down once, white following another white. Now, in this case, you still have 1 yellow ball left. So this is 1 out of 7. Okay, so we've got white, yellow as the outcome there. So that's 7 on 7 eighths of 56. And 2 whites is obviously going to be much more highly likely, isn't it? So that would be 7 sixes of 42 out of 7 eighths of 56. So this would be white, white. So the question is, what is the probability that one of them is a yellow ball, one of them? So we look at our outcomes. Well, we can't get 2 yellows, that's 0. So yellow, white, white, yellow. So 2 of these outcomes have 1 yellow ball, these 2 here. So we've got to add those probabilities. So 7 out of 56 plus 7 out of 56. And when you simplify that, you should get a quarter. 14 out of 56, which is a quarter. So that's going to be your final answer. So about 25% chance of getting a yellow ball. So not very likely, is it? Obviously, 2 white balls are going to be more common because nearly all of the balls are white. In question 6, the probability of Jeremy passing a maths test is 2/3 if he revises and 1/3 if he does not revise. The probability that he revises is 1/3. What is the probability of Jeremy passing the maths test? So we need to consider whether he's revising or not revising. That's the first thing. And in the question here, it says the probability that he revises is 1/3. So we normally do revision first before we do a test, don't we? So we put revision, not revision first. And the second thing is we'll do the test. This is the normal procedure when you study for a test. So your chance that he revises is 1/3. So if it's 1/3 for him revising, that means not revising must be 2/3. So you're either revising or not revising. So the sum of these 2 probabilities should equal 1. Okay. Now let's go back to the first bit of the question. It says the probability he passes is 2/3 if he revises. So if he revises, the chance of him passing is 2/3. So that must be here, 2/3, because he revises. He did the revision. So the chance of him passing is 2/3, which ultimately means that his chance of failing if it revises is 1/3. Again, these pairs of probabilities add up to 1. So don't just copy 2/3 down to here. And this chance of not revising is 2/3. So let's look at the question then. It says his chance of passing is 1/3 if he does not revise. Well, that makes some sense, doesn't it? So if you do revision, you're more likely to pass. So, and it's 1/3 if he does not revise. Let's see. 1/3 if he does not revise. So this is 1/3 here. And that means that his chance of failing is 2/3. So it kind of makes sense. You'd think if someone's revised for the test, their probability of passing is going to be higher than if they don't revise. And if they don't revise, the chance of failing is going to be higher than if he passes. So let's work out our outcomes. So we got revising and pass. We could have revising and fail, not revise, pass, not revise, fail, something like that. And so our probabilities will go here. So the chance of him revising and then passing is 2/3 times 1/3. So that's 2 on 9. Revising and failing is 1 on 9. Not revising and passing would be 2 on 9. And not revising and failing is 4 on 9. So that's actually the most likely outcome. And all of the probabilities are different except the first one and the third one. So what's the probability of him passing the maths test? So passing the maths test would be revising and passing, so this one, and not revising and passing. So there's two conditions where he may pass the test. And the first one is when he revises, he passes, or maybe he doesn't revise and he passes as well. So your probability then for your final answer will be 2 on 9 plus 2 on 9. So his chance of passing is going to be 4 out of 9, so a little bit less than 50%. In question 7, the probability of Jenny getting to work on time is 0.8 if she gets up before 7 a.m. and 0.4 if she does not get up before 7 a.m. The probability that Jenny gets up before 7 a.m. is 0.7. What is the probability that Jenny is late for work? So the normal procedure in the morning is that you wake up, don't you? So we put the waking up as the first event. Second event, you will go to work. And you can either get up before 7 here, or you can get up after 7 here. And in each case, you could either be late for work and always on time for work. Late or on time here. So we look at our question and we actually have to go down to this bit here. The probability that Jenny gets up before 7 is 0.7. So the chance of her getting up early before 7 is 0.7. Okay. And that means that the chance of her getting up after 7 is 0.3 because these probabilities must add to 1. So that's one thing to keep in mind. So do not copy 0.7 down here. It's not the same probability. So in this case, they add up to 1. So you either get up before 7 or get up after 7. Okay, so then we go back up to the question. The probability of Jenny getting to work on time is 0.8 if she gets up before 7. So 0.8 if she gets up before 7. So this is on time. So if she gets up before 7, her chance of being on time is 0.8, which means that her chance of being late is only 0.2. Again, 0.2 plus 0.8 must equal 1, because you're either going to be on time or you're going to be late. And then in the second bit, The chance of her being on time is 0.4 if she does not get up before 7. So the chance of her being on time is 0.4 if she gets up after 7 o'clock. So if this is 0.4, the chance of her being late would be 0.6. Again, these two numbers add up to be 1. So if that's 0.4, this one must be 0.6. And you get 1 there. So now we can put our outcomes on because now we have our numbers. So our outcome would be before 7 and late. We could be before 7 and on time. We could be after 7 and late, and after 7 and on time. So let's work out our probability. So 2.2 times 0.7, that's 0.14. 0.8 by 0.7, 7/8 of 56, so that's 0.56. 0.6 times 0.3, 0.18. 0.3 times 0.4, 0.12. Okay, what's the probability she'll be late for work? So now we look at all the outcomes that will make her late. So she could get up before 7 and be late. So that's this one here. And she could be late down here when she gets up after 7 and is also late. So these are your two possibilities. And when we take numbers from the tree, remember we add them. So 0.14 plus 0.18. So that's going to be 0.32 for the probability there. And that's your final answer.